Okay, these are some videos where I'm going to work through most of the homework problems for the final exam review. I think there are around 30 or so problems, and I will just simply go through these problems. Hopefully each of these videos will be maybe 15 to 20 minutes, and I'll try and work out all the problems. Once again, the problems on the final exam will look a lot like the problems in this review homework. So if you understand and can work these homework questions properly, you should do well in the final exam. So let's go ahead and start. Now actually the first two questions of this review both deal with working with quadratic equations or quadratic functions. So before I actually do these two problems, let me just take a few minutes and give you a quick review of how I like to think about these quadratic functions. And this may help us then when we actually look at the problems. Here's an example of a quadratic function. X squared plus 2x plus 5. So this is a quadratic. The key to a quadratic function or a quadratic equation is you have the variable squared. You have your variable squared. Once you have that, you have a quadratic equation or quadratic function. Example of a linear would be like, you notice there's no exponent on the variable. We call that a linear function. But now we're looking at quadratic functions where the variable is squared. This is also a quadratic function. Even though there's no x term, the whole key for it being quadratic is to have the variable squared. Now, one of the important things that you studied in this class was that when you graph, when you take a quadratic function and then you graph it, it ends up being what we call a parabola. So let's just take a minute and let's look at what a parabola looks like on the graph, and let's point out some of the important features of a parabola, because that's going to be important to help us answer some of these questions we're going to have. As it turns out, we can have two different kinds of parabolas when we graph a quadratic equation. The first looks something like this. Sort of looks like a U. And we say this kind of parabola, we say it opens up because it opens up. As opposed to a second kind of parabola we could have, we like to say this kind of parabola opens down because as it goes on, it's heading down. So every quadratic equation that we try and graph is going to look like one of these two parabolas. It's going to open up or open down. Now some key features of these graphs. First of all, for the parabola that opens up, if we go to the very lowest point on the parabola, right there, and on the parabola that opens down, if we go to the very highest point, these 2 points are very special, and they have a special name, and they actually have the same name. those points are each called the vertex. So if the parabola opens up, the lowest point down here is called the vertex of this parabola. If the parabola opens down, the highest point is called the vertex. As a matter of fact, one of the problems we're going to do in a minute, they talk about a quadratic function, and they use the word find the maximum or the minimum of the function. Well, if we think about if this was our function here, this vertex, we would say, is actually the minimum value of this graph or of the function, because it's the smallest value of that graph. And over here, with the parabola opens down, we actually would call the vertex here, it's like the maximum point or the maximum value of this graph, because it's the highest point. You're going to see in a few minutes, we're going to be given a quadratic function, and they're going to ask us to find either the minimum or the maximum value of the function. What we're going to do is basically, we're going to go find the vertex, because the vertex is the maximum or minimum according to what kind of graph you have. And there's another thing they're going to ask for in a few minutes. They're going to ask for, let me sort of draw it first. If I take either one of these parabolas and I slice them in half with like a vertical line, sort of right down the middle, as a matter of fact, this line goes through the vertex, and over here, it would look like this. These two lines they would call the axis of symmetry. I guess because the graph is symmetrical on either side of this line. As a matter of fact, what they're going to do in the problem, they're going to ask you to determine the equation of the line of the axis of symmetry. This is a vertical line. If you remember from graphing lines, if you write the equation of a vertical line, say for instance, the x value here is like, say this is 4 and this is 5. That axis of symmetry we would say is x equals 5. So when they ask for the axis of symmetry, it's just the vertical line that cuts the parabola right in half, and it actually always goes through the vertex. And the way you write the axis of symmetry is the equation of a vertical line. And then a couple other things while we're talking about graphs, so that when we do the problem, we can just give the answer is, they're also going to ask about the domain and the range of the graph or the function. Now when you have a graph, it's very easy to determine the domain and range. Hopefully you remember now, when we talk about the domain, we're talking about all the possible values of x, and we talk about the range, the values of y. What do we mean by all the possible values of x? When we look at this graph, we're going to give the domain as an interval, right? An interval where you first write the lowest value, comma, highest value. This is going to be our interval for either the domain or the range. So for the domain, you go to your graph. We need to look in terms of x. Say if we're looking at this parabola that opens up, I'm looking at the smallest value of x for this graph. In other words, how far in the negative x direction does this graph go? What's the smallest value of x for this graph? Well, hopefully you can see since I got this error here, this graph actually goes on forever, and it continues to get wider and wider. So how far does this graph go to the left? It actually goes to negative infinity. So if I would, for this graph, I would say the domain, negative infinity, this is an interval, then how far, the highest value, how far does this graph go to the right? Once again, because it keeps getting wider and wider, it actually goes to infinity. So the domain of a graph like this is negative infinity to infinity. Now how about the range? The range are the y's. The range, we're looking up and down. Once again, we're going to write it as an interval. In the interval, the first value is going to be the smallest or the lowest value. How far down does the graph go? And then how far up does the graph go? Say for this example, say right here, maybe that's a value of 2. So we can see this graph sort of starts at 2 and then goes up. So what would we say about the range? What's the smallest value of this graph in terms of y? How far down does this graph go? Well, this is the lowest point, and it's at 2. So we say for the range, it starts at 2, and since it includes 2, we put a bracket there. So 2 is the smallest value, the smallest y, the value of y of this graph. Then how high does it go? What's the largest value of y of this graph? Once again, since it goes on forever, we would say infinity. So we would say that the range is from 2, including 2, to infinity, the domain negative infinity to infinity. And then one last thing, they're going to ask you these problems. They're going to ask you to give the interval where the graph is first increasing and then decreasing. What that means is, so say if we look at this curve right here, you start way to the left of your graph, and as you move to the right, as you trace out the graph, as you move to the right, if you're going down, that means the function or the graph is decreasing. So far, it's decreasing, decreasing until you get here, until you get to the vertex. And then what happens after the vertex? As you keep moving to the right, the graph starts to go up. So all of a sudden now the graph is increasing. So for this half, it's decreasing. For this part of the graph, it's increasing. And you'll see when we do a problem in a minute, I would write the interval for negative infinity to this point right here, my vertex. That's the decreasing part. And the increasing part is going to start at my vertex, and it's going to go on to infinity. Now one last thing, not one last thing, but a very important thing is, if you're ever given a quadratic equation, it's very easy to graph a quadratic equation. To make a rough sketch, you only need 2 things. And this is another important idea about quadratic equations and graphing. I like to call it to make a rough sketch of a quadratic function. You need 2 things. Let me write them down, then I'll explain them. The sine of A, and we haven't talked about this yet, so I'll get to it in a minute. And then the vertex. Sine of A. My original, well, let me just make up a function. Maybe I'll actually work this out. How about, here's a quadratic equation or function. Now for some of you, especially when you start graphing, if it helps you, you can always replace f of x with y. means the exact same thing. So if it helps you, you can think of this as a quadratic equation. Now you remember when we worked with quadratic equations, especially if we ever used the quadratic formula, the way we like to write the general form of a quadratic equation, we like to write a times x squared plus b times x plus c, where the a, b, and c are just numbers or coefficients. So for instance, for our equation, a would equal 1, b would equal 2, and c would equal 5. Now what's interesting with this quadratic equation, up here I said I need two things to be able to make a rough sketch or to graph this quadratic equation. The sign of a. By sign, I mean, is a positive or negative number? So if I look at my example, a equals 1, so I say a is positive. Because here's what's interesting. Earlier I said there are two possible kinds of parabolas, open up or open down. Well, what's interesting is when a parabola opens up, a is going to be a positive number. If you look at the equation for that parabola, a is a positive number. And if you have an equation, it opens down. If you look, in that case, your a would be a negative number. So the bottom line is you can right away look at your equation and determine what a is. And if a is positive, you know it's going to be a parabola that opens up. If a is negative, it opens down. Very, very nice. Matter of fact, the way I sometimes remember whether a is positive or negative, I always think of a positive person as someone who smiles a lot, is very happy. So a positive a is like a smiley face. This looks like a smiley face. Meanwhile, a negative person frowns all the time. So I think of this as a frowning face, which means a is negative. So for our example, I said a is positive. So I know right away when I get ready to graph this, I'm going to have a parabola that opens up. Now the second thing I said to make a rough sketch, once you know the sign of a, because that's going to tell you whether it opens up or opens down, the next thing is to find the vertex. Because you know what? The vertex is going to be like this point right here. So I can graph that point, and then I draw an upward parabola, and I've got a rough sketch. It won't be perfect, but it'll be close. So the question is, how do I find the vertex? So once again, this is very important now, and you're going to have to memorize this because we've got a little formula. What I'm going to do is, when I normally talk about the vertex is a point on your graph, so it's got an x and a y. Matter of fact, I call it x with a little v for x of the vertex, and y little v for the y of the vertex. This vertex is a point. I need to try and figure out what this point is. What's the x value and what's the y value? The nice thing is, there's a little formula that we have that allows us to find the x value. The x value of a quadratic equation, or the x of the vertex, here's the formula, negative b over 2a, where once again, the a and the b you get from the original equation. So for our example, first you put your negative, then I set up here for our equation b is 2, so I put a 2 here, over 2 times A. A is 1, 2 times 1. Negative 2 over 2 is negative 1. For our problem, I've now determined that the x value of the vertex is negative 1. Now if I can figure out the y of the vertex, then we can plot the vertex, and really we can actually go ahead and just sketch the parabola. So how do I find the y of the vertex? What you do is, once we find the x of the vertex, you take that value of x. For our example, it's minus 1. And you take minus 1 and you go plug it back in to the original equation. So I'm going to go back to my original quadratic equation or function. I'm going to plug in negative 1 for x, and I'm going to calculate y. The y that I get is actually going to be the y of the vertex. So let me say that again. When we want to find the vertex, the x of the vertex, we use this little formula. Once I find the x of the vertex, I then go plug that number back in to the x of my original equation. And when I do that calculation, it's going to give me the y of the vertex. So in other words, to make it very clear, here was the equation we're working with. Since I found the x of the vertex to be negative 1, what I'm in a sense doing is I'm going to find the y of the vertex by plugging in negative 1 into x of the equation. Negative 1 squared plus 2 times negative 1 plus 5. This is 1 minus 2 plus 5. I believe it's 4. So the y of the vertex is 4. So my vertex, I've just discovered, is negative 1, 4. And if I wanted to, I could go just make a quick sketch. It may not be perfect, but it'll be close. What I'm going to do is I'm going to go plot the vertex. Negative 1, 1, 2, 3, 4. Right, here's the vertex. Because my A is positive, it opens up, and I can sort of make a rough sketch. So this equation here, x squared plus 2x plus 5, if you graph it, it looks something like this. So now, based upon all that information, let's go look at the first two problems, because the first two problems in the homework deal with quadratic equations. And the first problem asks you a bunch of questions, and the second problem is pretty short. So here is now problem 1 in the homework. Now for the homework I'm looking at, it may be different than yours. I mean, the function is going to be very similar, just the numbers might be a little different. So for the one I'm doing, it says I have a quadratic function, f of x equals x squared minus 6x. And if you want to, if it helps as you're working the problem, you can think of it as y equals x squared minus 6x. Now here's the progression of questions they ask, and I'm just going to go down through them. There's like 6 or 7 parts. First thing they ask, does the graph of f open up or down? So the graph is going to be a parabola. Does it open up or down? How do we know whether it's up or down? So the first question is up or down. Well, what's the sign of A? The sign of A determines whether it's up or down. Matter of fact, let's go ahead for this problem. Let's figure out A, B, and C. A is whatever number is in front of the x squared term. In this case, it's 1. B is the number in front of the x term, negative 6. Now C, there's actually no third term. There's no number here. So we just say C is 0. So does it open up or open down? What is A? Since A is positive, we know it opens up. So that's the first question, right? Very simple. Second question is, what are the coordinates of the vertex? So basically, they're wanting you to figure out this point, your vertex, the x and the y. Well, we just talked about that, right? The x of the vertex is this formula, negative b over 2a. And by the way, you will have to memorize this for the test. You will not be given that, so you need to memorize it. For this problem, we write the negative. B is negative 6, so a negative 6 over 2 times a. A is 1. So it looks like 6 over 2. It looks like the x of my vertex is 3. Now how do we go find the y of the vertex? Remember, I just take this 3 and I plug 3 in for x in my original equation. So I can say like y of the vertex is going to be x squared, so it's 3 squared minus 6 times x, 6 times 3. 9 minus 18. Looks like the y of my vertex is minus 9. So there's the next question. What are the coordinates of the vertex? 3 minus 9. Next question is they ask, what is the axis of symmetry? Now actually, in a minute or two, they're going to ask you to now graph this parabola. But you know what I can do just to help me answer some of these questions? I can make a rough sketch here. Once again, to make a rough sketch, you need to know whether it opens up or opens down, and you need to know the vertex. So let me go plot the vertex. 3, negative 9. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the vertex is here. Since A is positive, it opens up. So it may look something like this. Probably not exactly, but that's a rough sketch. I do that because the axis of symmetry, then it's very easy to see, right? The axis of symmetry is that vertical line that cuts our parabola in half. And once again, axis of symmetry is going to be the equation of a line. A vertical line, the equation of the vertical line is whatever the value of x is. This line goes through the vertex, so I know it's x equals 3. That's the axis of symmetry. Now here's something we haven't talked about. They ask for the x and y intercepts. X and y intercepts are actually very easy to calculate if you have your equation. For an x-intercept, it's just simply 2 steps. You take your equation, you set y equal to 0, and you solve for x. And whatever x equals, those are going to be your x-intercepts. And the y-intercept, you just flip it. You set x equal to 0. And then you solve for y, and the y's you find will be your y-intercepts. So let's do it. So once again, let me write it over here, my equation. Y equals x squared minus 6x. So for x-intercepts, set y equal to 0. So I have 0 equals x squared minus 6x. So I need to solve this. Solve for x. Well, let's factor out an x. Now hopefully, all of you know how to solve equations like this. The solutions are x equals 0 and 6, which in effect, which are the x-intercepts. So for the question about the x-intercepts, you would put 0 and 6. For the y-intercepts, you do the same thing, except you take your equation, set x equal to 0. should have y equals 0 squared minus 6 times 0. So when you look at this, y is going to be 0, which is your y-intercept. So you have one y-intercept of 0. Then they say, now in MyMathLab on your computer, they want you to graph this parabola. So now I made a rough sketch here, but based upon these intercepts, I can make an even more precise graph. So what I'm going to do is, now on your computer, the way you do it, I think you hit the little parabola key. And I think the way it works, so now we're going to try and graph this. First thing you do is you hit your little parabola key, and then you're going to go click on the vertex. So for our problem, the vertex, once again, is 3, -9. So right there is the vertex, 3, -9. And on the computer, then what you do is you click on the vertex, and then you choose one other point on your parabola. All you need is one point, and then it's smart enough to graph the parabola. Well, we just calculated x and y-intercepts. X-intercepts means those are the values of x where the graph crosses the x-axis. And we said 0 and 6. So we know actually the graph is going to go through here. 1, 2, 3, 4, 5. And when x is 6. And then if we look, the y-intercept is 0, so that point there is both x and y-intercept. So to graph this on the computer, you click on the vertex, you click on either one of these 2 points. Maybe you just click on this point, and then it will just fill in. My picture's not very good. It'll fill in the parabola. Then a few more questions which we talked about. It asks to find the domain and the range. We talked about that before. Domain is the lowest value of x, the highest value of x. Once again, this parabola continues to get wider all the time. So the smallest value of x is -infinity. The largest value of x is infinity. The range, now the range is up and down. So if we say, what's the smallest value of y for this graph? Well, it's right here at the vertex. And what's the value of y? -9. So the range starts at -9. Then how high does this graph go? What's the largest value of y for this graph? Infinity. And then the very last question is, determine where the function is increasing and where it is decreasing. So increasing and decreasing. And what they want these written as the interval of x. So we're looking at the values of x, and we're saying, okay, so as we start on our graph from the left to the right, what are the values of x where the graph is decreasing? So in this case, when we start at -x, as we move along our graph, we move to the right, decreasing, decreasing. It's decreasing until x gets to 3. And then as we keep moving to the right, as x keeps increasing, all of a sudden you see the graph or the function increasing. So we say for the increasing, for what values of x, increasing first. What are the values of x where this graph is increasing? Well, it starts down here when x is 3. And it increases, and where does it stop increasing? At infinity. This graph increases from 3 to infinity. Where does it decrease? Well, as we start here, -x, it's decreasing, 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 and it keeps decreasing until you get to where x is 3. So decreasing, it starts at negative infinity and keeps going until you get to 3. All right, so that was lots of parts of questions for the first problem. Now I'll quickly go into do problem number 2 because it's the same kind of problem but actually much simpler because they just ask a couple questions. So if you look at number 2, once again, they give me a quadratic function. In this case, my problem is 3x squared plus 6x minus 7. Let me read the actual problem. Determine, without graphing, whether the given quadratic function has a maximum value or a minimum value, and then find the value. So basically, two-part question. Does this equation, especially you can think about graphing it, if you were to graph this equation, what would you have, a max or a min? In other words, a maximum means it opens down, a minimum means it opens up. So which do we have? And then beyond that, they say, then go ahead and find the value of the max or the min. So basically then, after that, they want you to actually find the vertex to answer the question. Open up or open down is a very simple question, right? The whole key, the sign of A. For our problem, A is 3, B is 6, C is negative 7. What is A? A is positive, which means it opens up, which means for this problem we're going to have a minimum. So you click on the button for we have a minimum. Now they say, what's the value? What's this minimum value? What they're really wanting the y of the vertex, the value of the function when it's the lowest. But of course, to get the y of the vertex, what we have to do is first find the x of the vertex. Remember, the x of the vertex is negative b over 2a. Because once we find the x of the vertex, then we plug it back into the original equation, and that gives us the y of the vertex, which is what we want. So we have to find the x of the vertex first, and then we can find the y of the vertex. It's not very hard. A negative, b is 6 over 2 times a is 3. Looks like it's negative 6 over 6. Looks like the x of the vertex is negative 1. Now let's go find the y of the vertex, because the y of the vertex is what they're calling the minimum value of the function. Really, you can think of the y as the actually value of the function. You know, sometimes when we graph, we normally graph x and y, but you could, if you wanted to, instead of graphing x and y, you could graph f and f of x. So f of x and y are the same thing. So when they ask for the minimum value of the function, they're really wanting to know the value of y here. So let's plug negative 1 in for x in my equation. So 3x squared, plug in minus 1 for x, minus 1 squared, plus 6x, which is 6, plug in a minus 1 for x, minus 7. Negative 1 squared is 1, so this is 3 minus 6 minus 7. I believe this is negative 10. So we'd say the vertex is minus 110. So they would say the minimum value of the function, is negative 10. So this problem has two answers. You have a minimum and the actual value of the minimum is negative 10. All right, that was sort of long, but hopefully those of you who haven't quite understood maybe these quadratic functions and graphing and the vertex, hopefully this will help. So we'll stop this video now, and then we will start with problem 3 on the next video.